Hello, Python for Data Science community. Welcome back for another 7-minute hot take. Yeah, I know, these videos used to be called 5-minute hot takes, but I could never get everything done in 5 minutes, so here we are. In a previous hot take, we covered one of my favorite sources of example data, the UC Irvine Data Repository. Pulling data in real time from UCI can be an extremely useful tool, but there are a few other resources that I'd like to tell you about. They'll fill in any remaining gaps you have in your example data needs, and after this, you should never have to worry about or spend more than 5 minutes getting example data again. So let's get going. First, we need to import a Scikit Learn submodule called datasets. It will provide us with access to some stored datasets and some methods that we'll use to create and pull more. So let's do that now. So now that we've done that, we can use some of the methods that provides. Scikit Learn has a repository of smaller local datasets that are installed along with the module. You can get details on them from the Scikit Learn documentation, which I've pulled up on the right over here. And as you scroll through this, you'll get several lists of datasets that will be accessed in different ways. The first list that you will come to is this list of toy datasets that we're going to use that are installed with the Scikit Learn module. And you get to by doing load underscore and then the dataset name. So to load a dataset, simply use the appropriate load underscore method and assign it to an object. For example, to load the iris data, we use datasets.load underscore iris. Here's how that looks. So we'll run this to see what we get. And one thing to note here is that this method pulls in the data as what's called a bunch object instead of a pandas data frame. That means you access the data a little bit differently and you access the attributes of that data a little bit differently. So for example, you'll find the feature names in a feature underscore names attribute, and the data will be split into data and target attributes for your input and your outcome data respectively. Just an example of what that looks like. And you can see that in the console the feature names are printed. Check the docs for more information on what a bunch objects holds, and you'll get some more information by clicking through the links here. So that's a good way to load some quick data if you don't have internet access, or you're specifically looking for one of those classic data sets like iris, maybe for benchmarking for example. But let's say you want something a little beefier. The datasets module can do that too, by allowing you to pull down some larger datasets from the online Scikit Learn datasets collection. The format is pretty much the same as the previous command. We'll just use fetch underscore instead of load underscore. If you scroll down in the docs a little bit farther, you'll be able to see the list of datasets that are available through the fetch underscore commands. I'm going to control left just because it's a long page and we'll get to it quickly. Okay, so you can see here on the right in the Scikit Learn documentation the list of datasets that you can pull down with fetch underscore. Let's use the California housing data. So we'll run these two commands. The first will go out and fetch the California housing data from the online Scikit Learn repositories. And then the second will display what's in the data attribute of that bunch object that is returned. Again, this list of data sets on the right will help you figure out which one is most appropriate to your use case. And you can click through these links to get more information on each of them. Now let's say that instead of using something off the shelf, you want to create your own example data to certain specifications. Scikit Learn's datasets module can do that too. Let's say we want to generate some random data for a classification task. We want a binary outcome, let's say 1,000 samples and 10 features. The make underscore multi-label underscore classification method will do that for you in one line and allow you to set a random seed so that your work is reproducible. As you might expect, that's covered in this documentation as well. I'll leave that to you to read through in more detail, but I'll show you an example of how you might use it now. Okay, so what I've done here is I'm assigning to an object called multilabel underscore df the results of datasets.make multilabel classification. I've specified in the parameters that I want 1,000 samples, 10 features, and then I want the random state to be set at 1, 2, 3, 4. So that means that this should regenerate the same every time we run it. And of course, there are lots of different parameters you can set for make multilabel classification. Those will be covered in the doc. And as I was typing out, you may have seen that many more make underscore methods came up. So there are a lot of ways that you can generate random data for your for whatever use case you're working with. One final really cool thing that the datasets module lets you do is pull a dataset from openml.org. As of now, in October 2019, OpenML.org has over 20,000 datasets available for download. Now, some of these are essentially the same, multiple copies of the same data, and the interface kind of feels like the Wild West. But if you find a dataset you like, I'll show you one in just a second, you can download it by name in just one line after importing the fetch underscore OpenML submodule. So just a quick visual here. This is what the OpenML site looks like. You can see that there are different things that you can go to and take care of, not just the data sets, but to download data, you would go through the datasets search here. I've already got one pulled up, this ozone level data, and so we'll use this and fetch underscore OpenML to pull it down to our local environment. So we'll run this first line to import the fetch underscore OpenML method. Then we'll run it, and now we have an ozone object that has a data attribute just like we had before, and we can print that to the console to see it. So there you have it, essentially unlimited toy data that you can use for prototyping, benchmarking, whatever your heart desires. As always, the link to this code will be posted in the description, and don't forget to subscribe to be notified when new videos are released. And if you would like to see more videos on this topic, let me know by liking or commenting. Enjoy!